A cooling tower has an inlet cooling water rate of 5,000 GPM. The outlet temperature of the water is 85 degrees Fahrenheit. The cooling air enters the cooling tower at 80 degrees Fahrenheit and 50% relative humidity. The cooling air leaves at 85 degrees Fahrenheit and 89% relative humidity. The total airflow rate is 50,000 pounds per minute. How much of the inlet cooling water is evaporated into the airstream? So let's first draw a diagram of our cooling tower. So we have a cooling tower. We have some condenser water coming in. We have some condenser water leaving. We have air coming in and air leaving. So we know our air comes in at 80, 50. So 80, 50. And it leaves at 85, 89. We also know that our cooling water GPM is 5,000. And it comes in at or leaves at an outlet temperature of 85. So this guy's 85. So this condenser water will come in to the cooling tower, and generally you'll see like little spray nozzles on this hot basin. It'll spray water onto the fill, and that water will evaporate into this air that comes in through the sides or maybe through the bottom, depending on the type. But we know that the air is gaining heat. It's going from 80 to 85. And it's also gaining moisture, going from 50% to 89. So we can look at the psychrometric chart and look at the change in the grains of moisture in the airstream. So if we go to our PE handbook and go to psychrometric charts, I'm going to grab this guy and bring it over. Oh, that's big. Flatten that. Okay. So it comes in at 80, 50. So 80, 50, and leaves at 85, 89. So 85, and I'm just going to say 90. And then if we draw a horizontal line from both those points, we can see that our humidity ratio is 0.011, and our leaving humidity ratio is 0.0236. So our delta W is the difference between those two. So if I get my calculator, 0.0236 minus 0.011, which is 0.0126 pounds of water per pound of dry air. I'll tell you here. Sometimes this will be in grains. This one's in pounds. But we can see that our air is coming into the cooling tower at this guy here, and it travels along this path up here. So it's gaining heat, sensible heat here, but also this latent change here. So it's gaining moisture. Well, we know that the total airflow rate is 50,000 pounds per minute. So if we multiply this guy by 50,000, we have pounds of dry air per minute. So the pound of dry air will cancel, and we're left with pounds of water per minute. So I'm going to do the math here. So 0.0126 times 50,000 equals 630 pounds of water per minute. And now we just need to convert from pounds of water to gallons. So if you go to the PE handbook, we go to basic engineering practice. There's actually a conversion. It's already done for us. You can use this guy here. I'm going to grab this. So I'm going to divide this by 8.34. So 630 divided by 8.34 gives us 75.5. 75.5 gallons per minute, or GPM. So if we go to our options here, D is our solution.